Today we are going to look at what happens when you have a variable on both sides of the equation. And the big thing that can happen now is that you can get extraneous solutions. So you solve the whole thing, but you get one that doesn't really work when you plug it back into the original. To see what I mean, let's solve this first equation. Okay, we have 4x plus 10, take the absolute value, equals 6x. So I have two different equations to solve. I have 4x plus 10 equals 6x. Or I can have 4x plus 10 equal negative 6x. Now I'm going to solve both of them, so let's solve the positive one first. I'm going to move my 4x over to the other side, so I want to subtract 4x from both sides, and then I get 10 equals 2x. And now I divide by the coefficient, and I get 5 equals x. Oh, that looks nice. And now I'm going to do the negative one. So I'm going to do the same thing. I'm going to move my term with my variable to the other side. So I get 10 equals negative 10x. And when I divide by my coefficient, then I get negative 1 equals x. Now the trick is I have to plug both of these into this side of the equation. If when I plug them in, this side is negative, I know that's not actually a solution. It can't actually work because when I solve this absolute value equation, I am not going to get a negative. So let's plug it in and see. When I plug in the 5, that works pretty well. I just go 6 times 5, that equals 30. That's totally all right. So this solution is good. Now I'm going to plug in the other one and see what I get. Negative 1 times 6. Well, that equals negative 6. Uh-oh. This one doesn't work. This solution is negative. I cannot use it. Therefore, this equation only has one answer, and it is 5. Let's try the other example now. So on one side, I have 6x minus 1, and it equals 2x plus 9. On the other side, I have 6x minus 1, and it equals the negative of 2x plus 9. Now before I move on, I want to make sure I distribute that negative to all the terms. So then I have 6x minus 1 equals negative 2x minus 9. Now let's go back and solve each of these equations. So first thing, I'm going to move my 2x to the other side, and then I get 4x minus 1 equals 9. Now I got to move my 1 to the other side, so I add 1. And I get 4x equals 10. And now I need to divide both sides by 4. And I get x equals 2.5. Alright, on the other side, I'm going to move my 2x over here. So I'm going to add 2x. And I get 8x minus 1 equals negative 9. And now I'm going to move my 1 to the other side, and I get 8x equals negative 8. So now x equals negative 1. Don't jump to conclusions. We got to plug both of these in right over here. So when I plug in the first one, I have 2 times 2.5 plus 9. Well, that gives me a positive 14. That one's good. That one works. Now let's plug in the negative 1. I have 2 times negative 1 plus 9. Well, that just equals negative 2 plus 9, which is 7. In this case, both of these are a solution to the equation. So x equals both 2.5 and negative 1. Now I want you to try both of these examples. Try these on your own, so pause the video and try the example, and then you can turn the video back on. Hold on, not those examples. This example. Try this example, graph it, and then turn the video back on and see if you got it right. Alright, so now you can check your answer. You should have gotten x equal to 6 or x equal to negative 2. Because when you subtract the 3x from both sides in both equations, you end up with 18 equals 3x and 18 equals negative 9x. And then on the orange, you divide by 3 and you get 6x, 6 equals x. And in the blue, you divide by negative 9 and you get x equals negative 2. So when you plug those back in, when you plug back in 6 equals x, you get 36. That's positive. That's good. Woohoo. Over here, you get 6 times negative 2 equals negative 18. That's no good. We can't have negatives. So the only solution is x equals 6. And that's it for today. Tomorrow we will be looking at inequalities and absolute value.